So this is about books. Now we are again returning. So I think this slide is available. Are you getting?
Yes, sir.
Okay. So we had mentioned not in a tabular form, but you just observe the arc welding. So previously we had discussed gas welding, number two. So what are the different techniques? Oxyacetylene, oxy fuel. So oxygen, acetylene is the fuel, oxygen, hydrogen is the fuel. Okay, or oxygen, that is a supporting gas. Oxygen support combustions. So if we don't have oxygen, air may also be used, but that is not a good quality. So this is the oxy-fuel welding. Resistance, electric resistance welding. So we had discussed about spot welding, beam welding, spot, seam, projection, butt, percussions. Percussions means flash butt welding. This is what is known as this upset butt and flash butt. Acha. Now there are so many other and related process. Related process. This is not welding, but utilizes this oxy fuel flame. So what is that? Cutting. Related process mean instead of joining, that cutting is initiated, and basically for ferrous metal, what we had mentioned yesterday. So oxyacetylene cutting, or we may have also arc cutting, bridging soldering. So we shall not discuss this arc cutting or hard fishing for the time being. Bridging soldering, again this joining process. So that will again be discussed. Some newer techniques like electron beam welding, laser beam welding, then solid state, these are also newer, friction, ultrasonic, explosive bonding, diffusion bonding, all these are various advanced technologies. Then submerged arc welding, so those will be discussed. Thermite, so what we mentioned yesterday again, thermite is utilizes the chemical reaction as a heat source, and that may be either fusion or pressure. So these are various categorization, but not all. There are so many other things. Now for arc welding, perhaps at least you are familiar with this arc welding because during your laboratory in the most likely first year workshop, or when second year first semester there was a workshop on welding.
Yes, sir.
Yes,
Second
sir.
year,
Second, yes, sir. Second year, first semester.
First
Second
semester
year.
is second year
first year first semester.
No,
Second
sir.
year
Second
first
year, first
semester.
semester.
Okay, so the welding was discussed at least in theoretical mode,
In online mode, yes.
huh?
In online mode.
Online, but I think arc welding was discussed.
Yes, yes, yes.
Hmm. Now, in that case, arc welding. So again, as we had mentioned, uh, heat source or heat is a basic minimum in case of welding, right? So in arc welding, how heat is generated? Again, as the name suggests, electric. This is arc. Obviously, will be obtained from electrical sparks, right?
Yes, sir.
And in using electricity, we may have either electric resistance welding. So the concept is something different, where heat source is H equal to I square RT. But here, how heat will be generated, that we shall discuss. Again, as it is electrical source, so we may have either a DC set. What is DC? Direct current, right? And
Yes, sir.
one is transformer, AC transformer, alternating current, where there is no fixed polarity. Alternatingly, plus minus, these polarities are changing, alternating. But in DC, direct current, there are two fixed terminals, positive and negative fixed terminals. They are not changing. Okay, so and how heat will be generated, all these will be discussed. So we must have in arc welding, these are the requirements or equipments: a generator, DC generator, or transformer, AC, that is the heat source, either AC or DC heat source. Now, this cable means electrical conducting material, two cable wire, right? Two cables, two, why two? One for the work material, or not materials, parent materials, work material, which will have to be joined, and one for electrode. Now, here the concept of electrode is something different, not this positive terminal or negative terminal as the concept is utilized in electrical energy. But electrode in welding, in arc welding particularly, sometime in gas welding also some electrode rod is used. That is nothing but filler metal. So what we had mentioned yesterday, if we require some additional material to be deposited, depending on the gap in between the two pieces, which depends on the edge preparation. Again, edge preparation depends on the strength requirement or types of joints, depending on the geometrical shapes, sizes, all these. Okay. So here electrode is that extra filler material. So electrode. So here we require two cables. One is for electrode and another is for work materials. We must have electrode holder because job will be held in a work table. Jobs will be clamped. You did not hold the job utilizing any tongue or something, but electrode should be held manually. If it is robotic welding, obviously robot welders are there, robotic arms are there, they will grip all these. So we must have electrode. So as we require electrode cable for electrode, so we must have electrode. These are also very important devices in case of welding. These two: protective shield and gloves. It means this protective shield is a blue glass through which you should observe the flame or the welding position, what is going on, because you should not uh, look directly on the weld area, particularly arc weld area, through your naked eyes. Why? Because these rays which will be generated are very dangerous. That is, it contains ultraviolet rays, red rays, so that may contaminate your retina. Eye may be damaged. Okay, so that's why a protective shield is a shielding glass, also known as shielding glass, or a blue glass, a specially prepared glass. Not only the color is blue, but this is a specially designed, specially prepared glass through which ultraviolet rays, X-rays, UV rays, UV means ultraviolet, red rays, all these can't penetrate. And gloves are also used. Gloves, then other aprons, because gloves again, sometime you may feel some shock, electric shock, though there is a minimum chance, why we shall again mention, but gloves should be used. And also there are various bars and corners, that is sharp edges of metal, pieces of metals, wares. So that's why a gloves is an essential minimum. And also in welding industries, fabrication industries, where workers, or particularly the welders, are operating continuously throughout the day, they must wear apron, gloves, all these. And if you visit in some industries or fabrication industries, you will observe, just like today's in COVID scenario, what we had observed, the doctors, they are all the time, they are wearing these PPEs, personal protective equipment. That is, uh, all the body parts are completely covered. Similarly, in welding industries, in a fabrication industry, all the body parts of the workers are completely covered. Why? Because this, due to this arc welding or any other welding, various fumes or gases are evolved. Fumes and gases. Not only the rays, the red ray, X-ray, UV ray, but also uh, obnoxious gases are also formed. And that is also very, very harmful for not only for lung, but also for skins. Prolonged exposure with those obnoxious gases with your body parts may harm your body. That is, even skin cancer. It may lead to some various allergic conditions or other things, irritations, and even cancers. So that's why this protection in welding industry is very, very important. And wear brass to, after say initial wearing, welding, you should break the weld portion by a chipping hammer. So I don't know whether things had been demonstrated during your online classes, some videos or something. But if you go through some videos, there are various good videos in internet. So you shall observe that after say one deposition of say one layer of metal, say I just am trying to say this is piece and this is say another, they are to be joined here. So first a drop of metal or a oiled bead is deposited. So one drop of metal, that is oiled bead. Similarly, a second bead and third bead, it will be continued. Okay. So a solid joint will be prepared. But as soon as the first bead is deposited here, okay, immediately after that, or say you deposit, you continue, you fill the total gap here, first beading, whatever, just deposit a first line, and after that, you should use a chipping hammer. It is nothing but a just a striking edge. Here there is a striking edge made of iron. Okay, strike this portion, and as soon as it will be uh, the hammer will be used, uh, some layers will be separated. That layers are nothing but the oxide scales, oxide layers, because the welding is continued under atmospheric pressure or atmosphere. In room, inside the room, the atmosphere is there, atmospheric air, and this weld bead will be oxidized. Oxide scales will be formed. So immediately after one pass, using a chip breaker or chipping hammer, chip breaker or chipping hammer, remove the oxide scales and then clean this area just by using a wire brush. Wire brush is also used to clean the area, that is to remove any sort of dirt, dust, grease, etc. from this weld area. Otherwise, good quality weld will not be achieved. So after cleaning, chipping and removing these fragments, then go for second pass. Again, break the chips. Again, go for third pass. In this way, depending on the thickness, section thickness, or strength requirement, number of passes may have to be given. And all the time, as soon as one single pass is followed, immediately it should be followed by chipping. Why? To prevent or to remove the oxide scales. That's why chipping hammer, goggles, as I have mentioned, protective shield, goggles, all these are just for protection. So these are the requirements. And here, how the arc welding is conducted. This is a gross figure where this is the welding machine, that is either welding machine, either one AC or DC source, okay, along with control, etc. So this is the machine. And there are, say, as we had mentioned, whether it is DC or whether it is AC, we must have two terminals, positive and negative. In the DC, the terminals are fixed, that is, the polarities are fixed. But in AC, alternating, because AC, what is the sine curve? Okay. So
Yes.
alternatingly, sometime plus, sometime minus. So all the terminals are changing their polarities. But only two such poles are there, electrodes. That's why there are two cables. So one electrode cable, say this is this cable, this is a cable. Say this is connected with the electrode. This is the electrode holder, and on the top there is a electrode here. Electrode means a rod. This may be either, say, this is a bare wire. Bare wire means without having any coating material. So that may be electrode, bare wire electrode. Or generally in electrode some coating material is used, flask coating. So again we shall discuss in detail. So some coating material or flask material is used, just like what is agarbatti, dhoop, agarbatti, you are familiar with. So bare wire is the wooden stick on which some coating material are deposited. So something like that. This is the electrode, and this is the other cable, that is this other cable is connected with the workpiece or work cable. This is the work. And when arcing is initiated, this is the arc established, and this temperature of this arc is so high, the metal here will be melted. Okay. And also the electrode material will also be melted and will be deposited over here. So after the completion, one bead will be formed like this. So this is all about. But there are so many things. So this is the arrangement. Like in gas welding, we have two cylinders. One is oxygen cylinder, another is acetylene cylinder or other fuel cylinder. There are two cables and one chamber, mixing chamber, and either a cutting torch or welding torch. And this is ignited here, then heat is generated. But here, this is the scheme. Now, question is how, as in the previous slide, we are observing some arc. So as soon as these two cables or say work and the electrode are struck, and immediately separated by a small distance, air gap. Are you getting my what I would like to say? Say this is the workpiece and this is the electrode. So they are just struck, touch করা হলো, okay, struck,
Yes, sir.
and immediately make a gap, air gap. So through this air gap, arcing will be established, arcing will be continued, arc will be established, right?
Yes,
But
sir.
question is how this arc, is established. You are striking the two electrodes and immediately separating the electrode, maintaining a very small air gap through which arc is established. Now there are various theories behind this. One theory is electrical theory, which is not shown here, but say one is, this is second theory. First theory is electrical theory, not electron, electrical theory. Okay, electrical theory. And another is electron theory. Now, in electrical theory, first one, though it is not mentioned here, but you go through books, any books, uh, you will understand. Now, in electrical theory, what is happening? What is that theory? Electrical theory states that arc column is established when the two electrodes are struck and is separated by a small gap. Then how the arc is established as per electrical theory, right? So we have two terminals. One is anode, that is positively charged terminal, whatever, either work or mm, electrode. Forget about that first. Either work may be connected with positive or work may be connected with negative terminal or cathode or vice versa. I don't know. For the time being, you forget. But we have work, that is job, and we have electrodes. So two terminals. So either of them will be connected with positive or negative. And we have a, say, DC current source. Because why DC? Why DC? Can you say why DC? Because AC, I can't say this is a fixed positive terminal, this is a fixed negative terminal. All the time they are changing.
Yes, sir.
That's
Yes,
why,
sir.
yeah, that's why when this column theory or arc column theory is discussed, it is discussed on the basis of DC. Say I have a DC power source, DCPS, DC power source. It is written in books like this. DC power source, and this is the, I mean, the symbol that is used for power source. And this is one cable which is connected with positive terminal, another cable connected with negative or cathode. Now in electron theory, listen carefully. Electron theory tells that as soon as the two terminals are connected and being separated by a small distance, ions, what is ion? Positively charged, particles. Ions will be liberated at the anode terminal. Okay, number of positively charged particles will be liberated, and as they are positively charged, they will be attracted towards the opposite terminal, that is cathode. So this is the path, and they will be attracted towards cathode, and they will move from anode to cathode. And during such movement, so this is the ion flow. This is the ion flow in case of electrical theory. This is the ion. Okay. And when these ions are flowing, they will collide with the air gap. It is a small air gap, but air is there. So they will collide. And due to such collision, heat will be generated. Heat will be generated. But this discussion or this theory is not very strong theory, because a tremendous amount of heat is required to melt the workpiece. But how flow of ion can lead to the development of such tremendous amount of heat? That is not clearly understood by this electrical theory. So next development was the second concept, that is the electron theory. Electron theory. Now we know, we are not discussing, but if you again go through some books like say Little or any book, this is not needed, but for your understanding, you may go through any book, that is the electronic structure. What is the structure of an electron? You know, for any electron, in the center, there is a nucleus. There is a nucleus where there are proton and neutron in the nucleus center. And protons are positively charged particles, and neutron, they are neutral. And as this is positive, so it must have to be balanced. So in the outer shell, that is the orbital path, there are some particles moving. Those particles are electrons with negative charge. So this is the shell or orbital path. Okay. So this is a nucleus. Outside periphery, there are orbital path or shells. Number of shells may be there, K shell, M shell, N shell. So there are your, what is that? This in chemistry, that is key table, periodic table. So periodic table. So accordingly, there are so many elements. So number of proton, electron, etc. So that is other discussion. But this is the basis of this electronic structure. Now here, in electron theory, it is stated. Okay, let me just clean this. Okay. Now in electron theory, which is more strong, electron theory states that if the anode and cathode, that is the two terminals, are connected utilizing a DC power source, and as soon as they are struck and a small air gap is maintained, then not the ions are liberated, but electrons are liberated at the cathode surface. Just opposite, just think.
Yes,
Electrical theory states that ions will be liberated, but here electron theory states that electrons will be liberated at the metallic surface or cathode surface because electrons are easily liberated from the metallic surfaces compared to the ions. It is the phenomenon of any metal. Electrons can easily be liberated at the metallic surface. So when electrons are liberated, number of electrons, because thousands of electrons will be liberated and they will be attracted towards the anode surface, that is positively charged terminal, with a tremendous high velocity. So they will be attracted. So this path, this arrow, and this is the middle or column of the path. Electrons are migrating or attracted towards anode. And all the electrons, say a single electron, have a small mass, very small. What is that? 9.1, 10 to the power minus 28. Minus 28, so very small. But when not a single electron, thousands of electrons are liberated and they are moving, rushing towards the anode, right? And when electrons are colliding with the anode surface, they are attracted towards the anode and ultimately collided with the fouling. So this collision, this is a collision, is known as, this term is important, electron impingement. This calling impingement. Impingement. Similarly, some ions will also be liberated. When they're comparatively lesser in number, ions will also be liberated at the anode surface, and being positively charged particles, they will be attracted towards this cathode surface, and that will create the outer envelope, outer path. This is the inner column, electron column, and this is the outer envelope. They will also collide. They are also traveling, they are also attracted, they are also colliding the cathode surface. And this collision, ionic collision, is named as ionic bombardment. You should remember, though both are collision, দুটো গিয়েই ধাক্কা খাচ্ছে, দেওয়ালে ধাক্কা খাচ্ছে, কিন্তু ইলেকট্রনেরটার নাম হচ্ছে ইলেকট্রন ইম্পিঞ্জমেন্ট, আয়নিক কলিশনের নাম হচ্ছে আয়নিক bombardment. Now, so this is the science. Now, how heat is generated due to this? So, discussion is electrons have a very small mass, 9.1 into 10 to the power minus 28. When they are attracted or they are traveling with very high velocity, and are fouling, colliding, then this kinetic energy is given by, of a single electron, half mv square. You know this kinetic energy is given by half mv square for a single electron. So thousands of electrons are joining, and mass times velocity to the power 2, half of that. So that is kinetic energy of a single electron. So thousands of electrons. Now, when the electrons are moving with this kinetic energy and finally it is colliding, this kinetic energy will be converted into a heat energy. Are you getting the point? Due to collision or electron impingement. Another
Yes.
part of heat will come from this concept, that is, all the electrons not only have a small mass but also have a very small electrostatic charge, 4.8 into 10 to the power minus 10 coulomb per electron. So thousands of electrons will contribute to some electrostatic charge also. So in this way, there are two portions of heat generation. One is due to kinetic energy and one is due to electrostatic charge. Here also, anode will liberate some ions. They are also rushing with much less velocity compared to electron, and they will also collide. That is, kinetic energy will be converted into heat energy due to ionic bombardment, but they don't carry any electrostatic charge. So ultimately, major heat will be generated here on the cathode surface. Two-thirds of the heat, two-thirds of the total heat will be generated at cathode surface, and rest portion, that is one-third of the heat, will be generated in the anode surface. And due to the atomic collision in between, that is in the air gap in between, this is a medium heat zone, plasma area. Okay, medium heat. So this cathode area is high heat zone, anode area is low heat zone, this is a medium heat zone due to plasma or fouling with the atmospheric air. So this is the scheme: anode high heat, medium heat is cathode, is low heat, sorry, low heat. This plasma area is low heat. এটা বোধহয় উল্টো হয়ে গেছে। ক্যাথোডে টু-থার্ড, ইয়া, এটা ভুল হয়েছে, বুঝলে, এটা রং। দিস ইজ হাই হিট। ওকে, হাই। This is medium and this is low plasma area. Is it clear up to this, or any question on this?
আচ্ছা, বুঝতে পেরেছি।
Huh?
Yes, it is clear.
Clear to?
Yes,
So
sir.
now if this work, আচ্ছা, আগেরটা দাঁড়ান, এক মিনিট, আমি একটু ভুল বললাম এখানটা লেখাটা, সরি, নোট খেয়াল করবি। So just sorry, this is the this anode, right? So when electrons are liberated, they are striking here, and also as electron carries some electrostatic charge, so 2/3 heat will be generated here, not in the cathode. So this will be a high heat area. 2/3 will be generated here, and as only ions are colliding, ionic bombardment, only 1/3 will be generated. Just reverse. Sorry for. Okay, so this is the picture. This is the high heat. This is medium. This is low heat. So in the this is I mean, this is also wrong, but now just check this. Are you getting this thing?
Yes, yes.
Yes.
Previously, I just due to misinterpretation, because electrons are rushing here, so maximum, so the terminal, positive terminal will have maximum heat, negative terminal will have less heat. Based on this, say if now say this is the work, a job, and job is connected with positive terminal, positive pole. Say this is positive terminal of the DC, and this is negative terminal of the DC, and electrode is connected with negative polarity, negative pole. Okay, this is the job or work.